Hi guys, so we're going to start dealing with linear inequalities now, graphing them for the purpose of determining solutions to inequalities. And so there's a couple of key points we need to make here. Um, so remember an inequality, for instance, is y is less than x. It means that every time you pick an x, y must be less than it for it to be a solution to this. So if x here is 1, y can equal 0, that would work. If x here is 1 again, y can also equal -1, which would also work. If x is 2 and y is -1, that works. So long as y is always less than x, it is a solution to this inequality. And so that gives us a lot of information. It gives us a lot of solutions. And so it's convenient for us to graph this and then shade to make sure that we have found which parts should be shaded and which ones are actually the solutions of these. So there's some key points you need to know. Solid or dotted, okay, that's very important. And so when we go to graph this, you have to decide whether this line should be a solid line or a dotted line, dashed line, okay? And the way you do that is you simply look and see if it's included. If it's less than or equal to, meaning it looks like that would be a solid line. If it's greater than or equal to, that would also be a solid line. But if it's just strictly less than or greater than, either of these gives the dotted line. And what that means is that any point on that line itself is not a solution, whereas these two, any point on the line is a solution. Then the one final thing that you'll have to be able to do is you'll have to be able to use test points. Now, when we do test points, this portion, we're looking down here right now, if we do test points, you never want to pick something on the line. For instance, if I say 1, 1 is our test point. Okay, 1, 1 falls right here on this graph. Okay, there's 1, 1. The problem with choosing 1, 1 is, do I shade below this in the blue area, or do I shade above this in the brown area? Okay, it can be either side. The only indicator to us is the fact that y must be strictly less than x. And so if I choose a different test point, for instance, if I choose the point 2, 0, which is right here, let's see what it says. If I put 2, 0, we have 0 plugging it into this equation. 0 is y is less than 2. Is this a true statement? Is 0 less than 2? The answer here, of course, is yes, it's true. And so that means that this red point, 2, 0, is a solution. So that means we should shade the bottom portion that is red and not this top upper portion that was brown. Okay. So I think that that kind of indicates to you the importance of why you want to choose test points that are not on the line. Obviously 1, 1 is on the line. If you choose 1, 1, you're going to have some issues because you will not be able to determine which side of the line on the bottom portion where the red was, or the top, or where the blue was, and the top portion where the brown was. So I hope this gets you kind of prepared for what I'm going to be doing in the next video.